This tutorial is looking at geometric sequences, and by the end of the presentation you should be able to identify, construct and graph geometric sequences. So a geometric sequence, this is a sequence that's generated by multiplying by a whole number or a fraction to a fixed amount to the previous term, and it's called a geometric sequence. So basically you're looking at multiplying a term, so 2 times 2 to give 4, 4 times 2 to give 8, 8 times 2 to give 16, etc., etc., in order to get your next term. If you multiply by a fraction, like 8 times 1/2 is 4, 4 times a half is 2, so it's just like dividing basically. When we go through and do this, what we look for is a common ratio. So for arithmetic, we looked for a common difference. For geometric, we look for a common ratio. You can calculate the common ratio by actually dividing the current term divided by the previous term. So for instance, term n divided by term n minus 1, or term 2 divided by term 1, etc., etc. So take the next term, divide it by the previous, and then you've found your ratio. Make sure that if you do get a fraction, you do simplify it. Some examples of this. So we've got the sequence 3, 12, 48, 192. And if you do a division, 12 divided by 3, so term 2 divided by term 1, you should get the same result as if you did 48 divided by 12 or 192 divided by 48. All of these divisions give you an answer of 4. So the actual common ratio for this sequence is actually 4. For a different sequence, 16, 8, 4, and 2, you can do the same thing. So 8 divided by 16, 4 divided by 8, and 2 divided by 4. So note that's each subsequent term divided by the previous. And then this, when simplified, gives us a ratio of 1/2. Now, identifying if it is actually geometric. So for a number pattern to be described as geometric, the common ratio cannot change between each subsequent term. So as I go through and look at each subsequent term, it can't change. So 10 divided by 2 is 5, means that 50 divided by 10 and 250 divided by 50 also has to equal 5. So 50 divided by 10 is 5, and 250 divided by 50 is also 5. Therefore, we can say that this is actually going to be geometric, which is what we want. Example B, 3, 6, 18 and 36. 6 divided by 3 is 2, 18 divided by 6 is 3, and 36 divided by 18 is 2. I could have actually stopped at this point here with the 3, just because the 2 and the 3 are different, so I don't have a common ratio for this, and as such, I would be stating that this is not geometric. So graphing. Graphs of geometric sequences. We're only going to look at one example. Please note that there is, I suppose, different ways that this can be done, but the real thing that's in common for each of these is that you're going to find that they are not linear. There is a curve to your graph, and you'll see that when we go through and do this. So part A says find the next term. Note that the difference in each of these is that we are halving. So 32 times 1/2 is 16, 16 times 1/2 is 8, and then 8 times 1/2 will give you term 4, which is going to be 4. Part B said to find and put into a table the first 4 terms of the sequence. So we actually already have those. We calculated them. So 32, 16, 8, and 4. We are then asked to graph this. So putting up some sort of graph. Now, I haven't ruled this, so my scale is slightly off. Yours should be perfect. Please use a ruler. And then plotting in each of these points. When I did this, I started with my furthest distance, and then I just kept halving it because I knew that my ratio was a half. If my ratio was 1/3, I would be starting with 9 centimeters, and then I would have 3 centimeters, 1 centimeter, etc. So choose your scale carefully to make life easier, basically. And then if I plot these in, note that nice curve that I've got there. If we describe this, which is what we're about to do, it's a decreasing, decreasing with values approaching 0. It won't reach 0 though. So be aware of that, because every time you half it, it gets half as small, but half of a half is a quarter, a half of a quarter is 1/8, etc. So it gets really small, but it won't reach 0. So just a statement to describe the graph. Say if it's decreasing or increasing. Are the values approaching something? If they're not, then maybe they're getting exponentially larger. Just some sort of comment to attach to that.